Imagine you are just learning to play softball. You've always wanted to be a pitcher, but you don't know how to pitch correctly. You ask your coach for help and she agrees. You watch closely as the coach swings her arm counterclockwise once, then releases. You are amazed at how fast the ball travels and you don't really understand how it works. How did she know when to release the ball so that it flew horizontally?
The answer lies in the concepts of uniform circular motion. Uniform circular motion, also known as UCM, is the pattern observed by an object that travels the same circular path with a constant radius and a constant velocity.
Let's say you have a ball attached to a string. You swing the ball in a circle until the string is taut. The ball at the moment would be in UCM, or uniform circular motion, if the ball never accelerated or decelerated.
When a ball travels in UCM, there are two forces acting on the string that affect the ball's motion. One of those two forces is the centripetal force, the pull on the ball to the center of the circle. The word centripetal comes from two Latin roots, centrum, meaning center, and pedis, meaning seeking.
The other is centrifugal force, the pull on the ball away from the center. The word centrifugal also comes from two Latin roots, centrum, meaning center, and fugus, meaning fleeing. Now let's focus on just the centripetal force. The formula for the centripetal force is equal to the mass times 4 pi squared divided by the period, the time taken to complete a full revolution, squared. The diagram of UCM is considered a projectile graph. Recall that most projectile graphs have a certain direction of acceleration as well as a direction of velocity. As described before, the direction of acceleration is toward the center, the same as the direction of force. The direction of velocity is at a right angle to the acceleration. See how the velocity line only touches the circle at one point. This means that the direction of the velocity in the UCM diagram is tangent to the position, that is, the circle that the object travels. This is called tangential velocity. This means that as we were to release a ball in UCM at one point on the circle, the ball would travel in a straight line tangent to the line created by the point of release, and the center of the circle.
So, how is tangential velocity used?
Well, remember our softball example? The coach can tell when to release the softball so that the pitch flew horizontal to the ground. When she spun the ball in a circle, she created a centripetal force and a tangential velocity. When the ball was at its lowest point in UCM, the coach released the ball. Its tangential velocity caused it to move tangent to the radius on the point of release, which is vertical. That's how she could throw a pitch so straight.